Why are some reactions exothermic and some endothermic? Well, to explain that, we first need to understand that all molecules have a certain amount of energy. The more energy they have, the more reactive they are. Molecules with low energy are stable and less likely to react. So all molecules have some amount of energy to them. High energy, they are more likely to react. Low energy, they are stable. So molecules tend to be very stable. Remember the electron structures, the Bohr model, electrons in high energy orbitals would fall back down into low energy orbitals in order to become stable. So we're looking at stability. So let's start by looking at the energy diagram for an exothermic reaction. In an energy diagram, we have the y-axis, which is going to represent energy, and we have the x-axis that represents reaction progress. You can almost think of this as time. So in this graph, we have an exothermic reaction. I'm going to draw a line here, and this is going to represent the energy of the reactants. So the distance between this line and the x-axis represents the energy of the reactants. After a while, the reaction continues, and we end up with products. And this height represents the energy of the products. And we can see that the energy of the reactants is higher than the energy of the products. When the reaction happens, this is what the energy diagram looks like. It goes up, and then it comes back down. This extra height is the activation energy. The activation energy is the energy needed, it's a little bit of extra energy needed to start the reaction. Think about it as a spark. A fire goes on its own once it's started, but you need to give it that little bit of energy to get going. And the reason for that is you need to get the molecules moving fast enough so that when they bump into each other, they collide. If two molecules bump into each other and they're not moving with the right speed, then no reaction will occur. Now, because the products have less energy than the reactants, that extra energy, this difference in energy, must have been released. And this is why it's an exothermic reaction. The energy gets released, maybe you're touching it and you feel that heat, you see it as light, but somehow that energy leaves the products. In an endothermic reaction, the graph is very similar. We have energy, and we have reaction progress. This time, though, the reactants have less energy than the products. So in order to go reactants and products, more energy has to be added. So the reaction graph will look like this, the energy diagram, where this time, this is the activation energy. I'm going to label that AE for short. So in this case, in order to go reactants to products, overall we need to add energy. So this reaction will absorb energy when it occurs, and therefore it will feel cold because it takes energy from the surroundings in order to happen. Now I said before that low energy molecules tend to be more stable. So if we look at the exothermic graph, we go reactants to products, and you see that the products are more stable than the reactants. So it's very unlikely that the products will move back to the other side. Here, though, the reactants have less energy. So why does it still go to products? Well, because of this activation energy, once you make products, you still have to add more energy to get back to reactants. So the products kind of get stuck at this energy level, where you need to add more energy in order to get them back. So therefore, the products will remain products and won't quickly return back to reactants. Again, that does depend, though, on the exact reaction. The only other thing to point out here is, what if I add a catalyst? Well, a catalyst speeds up a reaction, but does not get used in the reaction. So a catalyst is going to lower the activation energy. So it lowers the height of the hump. So the red height is with a catalyst. It lowers the height of that peak. And again, a catalyst is just a substance that increases the rate of a reaction. It speeds the reaction up, but it does not get used up. If it did get used up, we would call it a reactant. But a catalyst speeds up the reaction by lowering the activation energy, so it requires less energy in order to go from reactants to products in both the exothermic and endothermic reactions. Lastly, one more thing about activation energy. The activation energy at the top of this peak is actually the energy needed to create what is called the transition state. And the transition state is kind of half reactant, half product. So this is just another kind of molecule. It's not very stable, but the transition state occurs at the peak of our energy diagram. So we have reactants, we get enough energy to get to the top of this peak and form the transition state, this combination reactant product. And then, because that's very unstable, it has a lot of energy. Look at that height above the activation energy. Then it will fall down, go to a lower energy state of the products.